Autism spectrum disorder, which includes what was previously classified as Asperger's syndrome, is a complex neurodevelopmental condition influenced by hundreds of genetic risk factors, many of which are polygenic, involving multiple genes, and conserved across evolutionary time. Direct evidence for ASD in ancient hominids is impossible to obtain, as diagnosis relies on behavioral observations unavailable from fossils. Instead, inferences come from genetic studies, archaeological interpretations of traits like exceptional focus or innovation, and evolutionary biology. Australopithecus, approximately 4 to 2 million years ago. Genetic risk factors for ASD are evolutionarily ancient, with many originating over 500 to 530 million years ago during early vertebrate evolution, far predating hominids. These genes were likely present in Australopithecus as part of shared primate heritage. However, with small brain sizes around 400 to 500 cubic centimeters and limited evidence of complex behaviors, full ASD manifestation is unlikely. Homo habilis and Homo rudolfensis, approximately 2.3 to 1.4 million years ago. Core ASD risk genes were almost certainly present. These early Homo species show the first clear tool use, Oldowan technology, which some interpretations link to traits like focused attention, potentially advantageous in ASD-like profiles. Homo ergaster and Homo erectus, approximately 1.9 million to 100,000 years ago, had larger brains up to 1,200 cubic centimeters. Advancements like controlled fire and Acheulean tools suggest potential for neurodiverse traits to contribute to innovation. Archaeological evidence of care for the infirm dates back 1.6 million years, hinting at social tolerance for differences, possibly including ASD-like behaviors. Still, full ASD expression is speculative without modern brain structures. Homo sapiens, Neanderthals, and Denisovans. Neanderthals and Denisovans branching off approximately 500,000 to 800,000 years ago. Ancient ASD risk genes were present in all, but specific variants and regulatory elements evolved differently. Modern humans inherited Neanderthal DNA through interbreeding around 60,000 years ago, and some variants are linked to increased ASD risk. In Homo sapiens, ASD traits are inferred from archaeological evidence, including detailed cave art showing hyperfocus and visual realism, traits common in ASD. These traits drove evolutionary advantages like technological specialization and systemizing skills. Did autism genes develop before the chimpanzee-human ancestor split? Yes, many core ASD risk genes predate the human-chimpanzee divergence approximately 6 to 7 million years ago. These genes are part of shared primate heritage, originating 500 to 530 million years ago during rapid gene radiation in early vertebrates. They are highly conserved with low mutation rates, involved in fundamental neural processes shared with chimpanzees and other apes. However, some ASD-implicated mutations occur in human-accelerated regions that diverge from chimpanzees, contributing to 1 to 5% of modern ASD cases. Thus, the genetic foundation is pre-split, but human-specific tweaks evolved later. Early Homo sapiens in Africa, from approximately 300,000 years ago, with behavioral modernity emerging 100,000 to 75,000 years ago, likely had ASD predispositions. As core genes were ancient and ASD exists today in African populations with minimal Neanderthal admixture, unlike Eurasians. Before the major out-of-Africa migration 70,000 to 60,000 years ago. Archaeological evidence from sites like Howisson's Port shows innovations such as microlithic tools, bone artifacts, and symbolic items. Interpreted as reflecting ASD-like traits, exceptional detail orientation, systemizing, and technological focus. These traits may have been advantageous in hunter-gatherer societies, aiding survival through specialization, such as tool-making experts and fairness systems. Prevalence is unknown, but genetic studies in modern East African cohorts show higher ASD rates up to 5%, suggesting deep roots without external admixture. Overall, ASD likely contributed positively to early African human societies, promoting diversity and innovation before global dispersal. The genetic foundations of autism spectrum disorder, deeply rooted in our evolutionary past, traveled with our ancestors as they spread across the globe. Today, our understanding of these ancient genetic patterns helps illuminate the complex origins of neurodiversity in human populations. From ancient genes to modern minds, autism represents a fundamental aspect of human cognitive variation, shaped by millions of years of evolution and adaptation.